In this video, I will discuss measures of central tendency. We will discuss how to find the mean, median, and mode of a population and of a sample, and how to describe the shape of a distribution as symmetric, uniform, or skewed, and how to compare the mean and median for each. So, a measure of central tendency is a value that represents a typical or central entry of a data set. The most common measures of central tendency will be the mean, median, and mode. The mean is calculated by adding up all of the data entries and dividing by the number of entries that you have. So you'll see this notation. It looks like an E, but it's a sigma notation. It's a Greek letter. And that means you'll see sigma x. That means add up all the data entries. The population mean and the sample mean are both calculated the same way. Population mean is denoted by the letter mu. Sample mean is denoted by x bar. But whatever the case, it's calculated the same way. You add up all the x values and divide by n, which is your total number of data entries. So let's look at an example. The weights in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? As you can see, we have 6 data values. 1, 2, 3, 4, 5, 6, 7. 7 data values, I'm sorry. So what we're going to do is we're going to add these data values up. We get 1,810. And then we're going to divide by the total number of data values that we have, and that will be 7. When we divide it out, we get 258.6. So the mean weight of the adults is about 258.6. The median is the value that lies in the middle of the data set when you have the data set in order. It also measures the center of an ordered data set by dividing it into 2 equal parts. If you have an odd number of data entries, the median is the middle data value, and if you have an even number of entries, the median is the mean of the 2 middle data values. So if we go back to this example, as you can see, it is not in order, so we're going to put it in order. Since we have 7 data values, which is an odd number, the median would be the number directly in the middle. So the median weight of adults is 268. So let's say we go back to our data set and the person that weighed 285 pounds decides not to participate in the study. What is the median weight then? So if we took that person out, we have 6 data values, and that's an even number. So what we have to do is we have to take the mean of the middle 2 numbers. And as you can see, we get 251.5. So you take 235 plus 268 and divide by 2. The mode is the data entry that occurs with the greatest frequency. If no entry is repeated, the data set has no mode. If 2 entries occur with the same greatest frequency, each entry is a mode. It's called bimodal. So let's look at this example. This is our previous example. We're going to calculate the mode. The mode is the number that appears the greatest number of times. So in this case, 235 appears twice, whereas all the other data entries appear once. So the mode for this would be 235. Now let's say, for instance, we did not have an extra 235. We just had one 235. If you look at this, there will be no mode because each data value occurs the same amount of time. So this would be no mode. At a political debate, a sample of audience members was asked to name the political party to which they belong. The responses are shown in this table. What is the mode of the responses? So you got the political party and the frequency. So Democrats has a frequency of 46, Republicans has a frequency of 34, Independent 39, and other don't know will be 5. So the response occurring with the greatest frequency is Democrat. So the mode is Democrat. In this sample, there were more Democrats than people of any other single affiliation. So all three measures, the mean, median, and mode, describe a typical entry of a data set. The advantages of using the mean is a reliable measure because it takes into account every entry of a data set. The disadvantage of using the mean is that it's greatly affected by outliers. And an outlier is a data entry that is far removed from the other entries in the data set. For example, if I had 1, 3, 5, and then 1,000, we would consider 1,000 to be an outlier because it's greatly is far away from the rest of the data values. So I'm gonna show you how to do these calculations in StatCrunch and Excel. You don't have to do these calculations by hand. If you do not want to, you can have technology to do it for you. So I'm not going to do this particular problem, but I wanted to show you how to transfer your uh, data sets into StatCrunch or Excel. Okay, so and I have a video out on this already, so you may want to refer to that video. But if not, you have this little button. So when you're doing your homework and you have a data set, you'll see this little button. And what you do is you click on it, and it gives you the option to open the data set up in StatCrunch, or you can open it up in Excel. Okay, so let's go ahead and do a problem. And it says the table shows the sample ages of students in the class. We're going to find the mean, median, and mode of the ages. Are there any outliers? What measure of central tendency best describes the typical entry of this data set? So these are the numbers, the answers when you do it by hand. So the mean is 23.8, the median is 21.5, and the mode is 20. So let's go ahead and do this in StatCrunch. So I already have the data values typed into StatCrunch. You don't have to type them in. Like I said, you can transfer them over into StatCrunch. So what I'll do is I'll hit Stat, Summary Stats, Columns. And I want to select the column that says Ages. If you look in this box here where it says Statistics, you'll see different ones that you can calculate. But I don't want to calculate all these. I just want certain ones. I want the mean, median, and mode. So I'm going to click on the mean, and as you can see, it appears in this box over here to the right. I'll scroll down and I want median. Now, if I click on median, the mean disappears. So what I'll do is I'm going to hold the control button on my keyboard and then select median at the same time. So as you can see, median appears. I also want the mode. So I'm going to hit the control button on my keyboard, hit mode, and as you can see, I have all three in the box to the right. And I hit compute, and I get the same answers, 23.75, 21.5, and 20. In your homework, it will tell you what decimal place to round to if you do have a decimal. So in this case, you can round this to 23.8 if they ask you to round it to one decimal place. Now I also have an Excel template here. And if you would like to work in Excel, that's fine. I always encourage students to learn Excel because when you go out into the real world, you will not have access to StatCrunch. So if you want to mess around with my Excel template, that's fine. I'm going to go ahead and type the data values in. And what will happen is, once I have everything in, the template is going to calculate my answers for me. Okay, so in this template, I have everything over here in the column. So it says enter your data values in column A, and that's what I did. So column A will be specified with the color. And I type my data values in, and below, the boxes in yellow will be the answer. So I have the mean, median, and mode. And as you can see, we got the same answers as we did with StatCrunch. So if you want to know the command for mean, click on the answer, and the command will come up in this box up here. So the command for mean is the average, and you have to specify what what column your data values are in. You can do the same thing for median. The command for median is median. And then for mode is a little different. It's mode.molt. And the reason why I have molt in there, M-U-L-T, is sometimes data sets have more than one mode. Okay, so if you do it this way, it'll it'll display all of the modes in there. If you eliminate the mult, the MULT, it will only come back with one mode. So you really want to use that command so it displays multiple modes. Okay. So this is a summary of our answers, and as you can see, the mean takes into account all of the data values. So it's going to be influenced by that data value 65. If you look at the data set, most of our numbers, or the majority of our numbers, are in their 20s, except for this 65. So this 65 can be an outlier because it's far away from the data. So as you can see, the mean is 23.8, whereas the median only looks at the middle value. Therefore, it's not affected by outliers. So in this case, the mode actually exists, and it doesn't appear to represent a typical entry. We have 20. If you look at this graphically, we have the 65 all the way out here, and there's a gap between the 65 and the lowest number. It's a big gap. So as you can see, the mean is pulled away from the median. The mean is greater than the median, and that's because this 65, when you used it in the calculations for the mean, it made the mean a little bit higher than the median. So when that's the case, when you have outliers, it's best to use the median to describe the center of your data. When your data set is symmetric, like bell shape, the mean is the best measure for the center of your data. So let's look at a symmetric distribution. A symmetric distribution is when the sides mirror each other. So if I put a line directly in the middle of this graph and I fold the paper, the sides, both sides, or both of the sides of the graph should meet up. So we call this symmetric. We call this bell shape. As you can see, when it's perfectly symmetric, the mean, median, and mode are all equal. This is a uniform distribution. All entries or classes in the distribution have equal or approximately equal frequencies. This is also symmetric. The mean and the median will be equal to each other. This type of graph is skewed. It's skewed to the left, negatively skewed. So the tail elongates more to the left. So an example of this, if you think of the heights of females. Let's say you're in the classroom, and let's say everybody or most of the people in the classroom are between 5 inches, 5 feet 4 inches to about 5'8". Okay, but then you have a very small person. Maybe you have a midget that came into the classroom. She's female. You took her height, but she's all the way down here. She might be 4 foot tall. So that's considered an outlier because her value, her number is not frequent. It's not close to the rest of the classroom. So her height will skew this data to the left. So when you have outliers, you can have outliers on the high end. You can have outliers on the low end. So this is considered an outlier, and this will make the data skew to the left. On the flip side, you have skewed right distribution, and that's positively skewed. And the tail of the graph elongates more to the right. So if you look at this, once again, we can use the height of females. Once again, the heights of the females might be 5'4" to 5'8". But then you get this really tall person. Maybe she's a basketball player and she's 6'9". So her height will fall out this way. As you can see, that height is far away from the rest of the data. So it will stretch the graph out to the right. As you can see, if we go back to the left distribution, the mean is less than the median, and the median is less than the mode. Okay? If you go back to the right distribution, the mode is less than the median, and the median is less than the mean. Once again, the outliers will cause the mean to stretch out towards the outlier. So as you can see, this mean is going towards the outlier, and if you look here, this mean here is going out to the left because that's where the outlier is.